Hi everyone. For 8.2, we're going to take what we learned yesterday about exponential graphs and we're going to combine it with something we learned earlier this year, transformations. The first time we talked about transformations, we did absolute value graphs. But if you remember, I told you the transformations you learned, it's a super important lesson because it applies to any graph you ever learned. So that's what we're going to focus on today. We're going to take our transformations that we learned way back in 4.7. We did it for absolute value graphs. And we said these same transformations work on any graph you've ever done or ever will do, including exponential. So that's what we're going to do today. We're going to take the exponential graphs we saw yesterday, and we're going to apply transformations to them today. So let's do a review of our transformations. The first type of transformation, the official math name is translation. I usually call it a shift because you're just taking your graph and you're moving it. You're either going to slide it up or down or left or right, one of the four directions. And a translation happens when you take your function, today it'll be an exponential function, and you add a number to it. So if you add a number to the function itself, that's going to shift it up or down. If you add a number, it shifts up. If you subtract, which is basically adding a negative, it shifts down. So for example, if I ask you to describe, and that's what you're going to do in the homework today, you're not going to do graphing, you're going to do describing. So if I ask you to describe the transformation for y equals 2 to the x plus 4, you say, okay, well, 2 to the x is like my starting function. What I'm really asking you here is, what does this plus 4 do? Well, this plus 4 takes the graph and shifts it up 4. Now, remember when we talked about transformations the first time, we said anything you do to the function itself is always a transformation that moves up or down. Anything you do to x is always a transformation left or right. So I said if I take a number and add it to the x in the exponent, that's going to shift it right or left. So for example, this is very, very similar. The first one was 2 to the x with a plus 4 in the end. This is 2 to the x plus 4 in the exponent. So you can see what I did here is I put the plus 4 on the x instead of on the end of the function. Now that makes it a shift right or left. And remember from 4.7, same rules today. You got to remember this one because it's kind of backwards. It's like the opposite of what you'd expect. Usually, like when you're plotting a point, you think if it's a plus, you shift to the right, and if it's a minus, you shift to the left. This is actually it's backwards. It's the opposite. If it's a plus 4, you shift left 4. If it was a minus 4, you would shift right 4. So let me show you a quick sketch of what this looks like. Let's say, for example, that this graph right here was 2 to the x. If I asked you to graph 2 to the x plus 4, all I'm going to do is I'm going to take that graph and I'm going to shift it up 4 spots and I'm going to draw it up here instead. So see how I took that and I just took the graph and I shifted it up 4 spots? Now for the other one, I'm going to start with 2 to the x again. So this is my starting function. Let's say this is 2 to the x. It's like one of the graphs we learned yesterday. This one would be shifted left 4. So this one I would start over here and end up drawing it kind of like this. So see how that one, to go from white to yellow, I shifted to the left 4 spots? That's what we're doing with this. So in both graphs, the white graph was just 2 to the x. The yellow graph is the transformation. If I put a plus 4 on the end of my equation, it shifts it up 4. If I put a plus 4 on the x inside the function, it shifts to the left 4. Okay, our second transformation is a reflection. Reflection comes from multiplying by a negative. So I'm going to do 2 to the x again. Now if you notice on the first function, I took the 2 to the x and I multiplied by a negative outside the function. Now remember, that's always up and down. So what that does, and I'll draw a quick sketch for you again. Let's do the same way we just did. Let's say this is my graph of 2 to the x right here. If I was graphing that top one, negative 2 to the x, what it does is it flips it upside down. It's a reflection, and it's going to make it like this instead. Going to make it the yellow one. So this is negative 2 to the x. And I put parentheses when I typed it. You don't really need them, but you can have them there if you want them. Now, for the second one, what I did is I put the negative on the x in the exponent. And remember, the difference is, if you do it to the function itself, it's always up and down. If you do it to the x, it's left and right. So what that would do is it would take my graph 2 to the x, and I'll start with 2 to the x again like this, and it's going to mirror image it right here, like make this the mirror, the y-axis. So what it's going to do is it's going to take that part on the right and flip it over like this, and take the part where it flattens out and turn it like this. What it actually does, if you want to use your vocab from yesterday, it turns an exponential growth function into a decay function. So this is 2 to the negative x right here. So if you multiply the exponential itself by a negative, you get the first picture where it flips it from top to bottom. And if you multiply the x by a negative, you get the second picture where it flips it side to side. All right, our third transformation is called a dilation, or what I usually call a stretch, because it stretches the graph, it changes its shape. We said multiplying by a constant, by a number, stretches the graph. So for the first one, if I took my 2 to the x and I multiplied it by 5, that's what I'm doing right here. Taking my 2x and I'm multiplying it by 5. What it does is it stretches it taller. Now the stretch is the hardest one to draw, but what's going to happen if this is 2 to the x right here? Imagine me pinning the graph down right here and grabbing the other arrow and pulling it and stretching it so it's taller. So what it's going to do is it's going to kind of go more like this, be a taller graph like that. I knew I went right onto our notes, but that's okay. So it's like grabbing it and stretching it taller. Now the second one, even though it's hard to see now because I wrote over it, if I multiply the x by 5, then remember, it goes sideways instead. And also remember, those are backwards. So what it's going to do, instead of grabbing it and stretching it sideways, it's actually going to take it and squish it sideways. It's going to do a compression. So for the second one, if this is 2 to the x, one more time, it's our last one for today. If I wanted to graph 2 to the 5x, what it's going to do is, imagine me putting my hands on the edge of it and compressing it to 1/5 its size. So what happens is this part squishes in so it's much closer to the axis, and this part kind of does almost the same on that side actually. It's hard to see a compression on that side. But it basically would take it and kind of squish it in like that. That's the hardest one to do. But that's a quick review of the transformations for you guys from 4.7 and how they apply to exponential graphs. And that's what you guys are going to do in the homework. You're going to focus mainly on actually putting in words describing what would happen. So that the homework might say, if you have a graph of 4 to the x and you're supposed to graph 4 to the x plus 10, describe the transformation. And you would say, I would shift it up 10, that kind of thing.